Now we are going to discuss the form of potential energies. For example, a chemical potential energy is stored in food we eat. The stretch elastic band is stored in elastic potential energy. Some examples are a spring, slide shoots, and a battery contains a chemical and a electrical potential energy. Now look at this one diagram that a boy takes a brick in an upward, it stored a potential energy, and it's release a brick, it's converted into a kinetic energy. When a man moves in upward direction, upward steers, it stored some potential, gravitational potential energy. When you take a ball in upward direction, you stored in gravitational potential energy, and when you release, it's converted into a kinetic potential energy. Now look at this one car. The car moves in upward direction and it stores a potential energy, and when the car comes downward direction, it's take out the energy, means release the energy, which is a kinetic energy. Now we are going to discuss about the power, that a power, and explain the power. Power is the time rate at which work is done. Mathematically we can write a power equals to a W by T. So the unit of the power is a scalar quantity, and SI unit of the power is watt. 1 watt equals to a 1 joule. Joule is the unit of the work, and second is the unit of the time. So 1 joule equals to 1 joule, 1 watt equals to 1 joule by 1 second. So we can write in a, symbolically 1 W equals to a 1 G as minus 1. Other units, the British systems, the unit of the power is a foot pound per second, feet lb by s. For potential, for practical purpose, the large unit is often used in a horsepower, HP. The symbol is the HP, which is defined as a 550 feet lb by equals to a 746 watt. So 1 HP equals to a 746 watt. The unit of energy or work can be defined in the terms of power. 1 kilowatt hour is the energy which converts or consumes in a 1 hour at the constant rate of 1 kilowatt equals to 1000 joule by second. Numerically, 1 kilowatt equals to a 10 raised to the power 3 watts and 3600 seconds. So 1 kilowatt equals 3.6 multiplied by 10 raised to the power 6 joule. Example is the definition of work makes no reference to the passage of time. For examples, if we lift a beer bell weighing 100 Newton through a vertically distance of a 1 meter at constant velocity, we do 100 newtons, and 1 meter equals to 100 joule of work, whether it takes 1 second or 1 hour. But we need to know that how quickly work is done. So it is described in terms of power. Look at this one diagram that it's running and time is recorded. Clear? And this P equals to a W by T, and when it moves in the upward direction, we know that a W equals to mgh. So it's a mgs by T. Power in physics, that a P equals to a work by time. The unit of work is joule and the time unit is a second. Thank you.